Hi everybody! In this video you're going to learn how to do synthetic division. So go to the next spot in your notes after the long division notes and title your notes synthetic division. This is a new thing we haven't done yet before. It's basically a shortcut for long division. Now make sure during this video, if it is on mute, you take it off mute right now so you don't miss any of the important information here. Also make sure you write down everything I say and everything I write down here. These are basically the notes. This way we don't have to sit in class and write all this stuff out. And then I have about 3 or 4 examples. The last one's for you to try on your own. Alright, so far you've done long division. The key here is we want to break down a polynomial. So whatever the degree is, we want to lower the degree repeatedly until it's all linear factors. The ultimate goal is to be able to factor polynomials, mainly ones that looked unfactorable. Like for example, if you tried grouping, it didn't work, you couldn't factor an x out, you couldn't do guess and check. That's when polynomial division comes in handy. Now, long division only factors a polynomial when the remainder is 0. You can do long division with any 2 polynomials that you want. It's just you'll end up with a remainder a lot of the times. Sometimes you'll get 0. And that means that you actually did factor the polynomial. So from now on, we're really going to want remainders of 0 because our goal is to factor it, not just to do long division for nothing or synthetic division for no reason. And whenever we factor the polynomial, the degree goes down by 1. We'll talk about that more next week as well. Now, the one nice thing about long division is that you can use it for any polynomial division. It doesn't matter what they are or what the degree is. Obviously, the bad thing is it takes a very long time. It's a little bit tedious. There's also a lot of room for error, especially with all the negatives and the subtracting. So mathematicians came up with a nice shortcut, and it's called synthetic division. I'm not sure why they chose the word synthetic, but there must have been a reason. Anyway, it is much quicker. The only thing with it is limited. Long division is not limited, synthetic division is. You can only use it when you're dividing by a linear factor or a linear term, basically something in the form x minus k. Keep in mind the reason it's called a linear is because the degree here is 1, and if you were to graph this thing, it would be a line, so that's why it's a linear line factor. So pause the video, make sure you have all this written down, and then I want you to look at these 3 polynomials. And just look at these and see which of these do you think you could use synthetic division for, based on what I just said here. Now realize that this is a linear factor. The degree is 1, so we can do synthetic division. We're good to go. This right here definitely could not be used with synthetic division because, so no synthetic. The degree is not 1, you would need long division. So in this case, if you really wanted to divide these, you would put the 2x to the 5th down here, and then you would put your x squared minus 8x plus 1, and you would do the whole long division process. This one here, some people think at first that you can do synthetic division because there's only 2 terms here. It's a binomial, just like this. But notice the degree is not 1 here, the degree is 2. So again, no synthetic. And you would again need long division. So if you only need a linear factor, then synthetic division is very nice. So what I have here is I want to do synthetic division side by side with long division 2 times just so you can compare them and see how they're related because they are very related. So here's an example. I'm taking this cubic and I'm dividing by this linear term. So I can obviously do long division with it because you can do long division with anything. As you copy this down, make sure you're following along and you realize how I got all these numbers and you agree with everything I did. Here's my remainder and here is my summary statement. So notice when I write out my summary statement, it's not factored perfectly because I have this remainder of 5, but it is still true. If you were to FOIL all this out and add 5 to it, you would end up here. It's just we didn't really factor it perfectly. So let's try the synthetic division. Now notice the most important thing with synthetic division is if you're dividing by x minus k, or just using a k here for a number to make it general for anything, you must use k in your synthetic division. So synthetic division, the setup is very easy. Instead of having your division bar look like this, you basically flip it upside down and make it a little bit larger. Give yourself 2 lines of room in here. And this whole x minus k business, in this example, I'm dividing by x plus 2, which does not look like x minus k. If you wanted to force it to look like minus, it would be x minus -2, and then -2 is your k. So if it helps you to think of it like this, whatever number goes here, first of all, it is k. It's basically the opposite of what was here. And then synthetic division, the reason it's such a shortcut is because you only use the coefficients of every term in your dividend, or the larger degreed thing. So I'm only putting those here, and just realize they're in descending order. So this was your x cubed, x squared, x, constant, coefficients. And the way synthetic division works is this. So make sure you've copied all this down. Pause the video if you haven't so you can do this along with me. So I'm bringing the 3 down. You always bring the first number down here. You don't do anything else but drop it. Then you always multiply by k. So I do 3 times my k. 3 times -2 is -6. Now the nice thing about synthetic division is instead of subtracting, like long division, we subtracted every single row. And that leaves more room for error because generally people make more mistakes when they subtract. With synthetic division, you add vertically. That says vertically? Oops. So you lose some room for error. And the reason you add is because this has the opposite sign. That's the reason we put the opposite sign here. So a -2 instead of 2 so that we can add. Okay, so a plus -6 is 2. Now multiply by k again. 2 times -2 is -4. Add vertically. 5 plus -4 is 1. Multiply by k. 1 times -2 is -2. Add vertically. And check it out, the remainder. Now I also want you to look, you might be thinking, okay, that's fine, but these are just numbers. Like, what do these numbers mean now? Here they had more meaning. You could see the polynomials, how they looked. Notice this and this. The coefficients are the exact same. In this case, these numbers make up your quotient. This number here, you box it off usually, so you remember it's the remainder. Remainder will always be the last number here. And then you have to write this so it looks like a polynomial again. We turned it into just numbers. We made it look not like a polynomial, so let's make it look like a polynomial. You could just remember that the degree always goes down by 1. So if this was a 3, this one right here needs to start with a 2x squared. Or you could start right next to your remainder right here and realize this is your constant, so x to the 0. Moving left, this is x to the first. This one would be x squared. If there were more numbers down here, it'd be x cubed, x to the fourth, etc. So now you have to write it out so you still have your summary statement. So my original, which was this, I'm not going to rewrite that. That equals 3x squared plus 2x plus 1 times what I divided by. So make this look like a factor again. X plus 2 plus 5, because I was dividing by x plus 2. So you have to put plus there again. And there you have it. Same remainder. Obviously same remainder. Same summary statement. So pause the video, get that all down in case I went quicker than you were writing. And next example. So one more time, I'm going to go side by side with long division, and then I'll just do a couple quick synthetic division ones just for more practice. So here's the long division example. I have this cubic divided by this linear term. As you're copying this down, make sure you're okay with everything I wrote. And notice my remainder is 1, so it is not factored perfectly. Here is your summary statement. So let's do synthetic, which is about 5 times faster. And notice I highlighted all my coefficients, and all my coefficients went here. Also notice you need to keep the sign in front of the coefficient. Oops. So let's go ahead and do it. If I have a factor x plus 1, that means k is -1, so I'm dividing by -1, the opposite of what was here. So drop down this number always and multiply. 4 times -1 is -4. Add vertically. 10 plus -4 is 6. 6 times -1 is -6. -3 plus -6 is -9. And then -9 times -1 is 9. Oh, we almost had a perfect remainder here. Not quite. So -8 plus 9 is 1. So there's your remainder. And then starting from the right, this is your constant, x to the 0, x to the 1, x squared. It goes up by 1. And notice this was your x cubed term. X to the first. So if your degree was 3, you always break it down by 1. So same exact summary statement. This original thing here equals whatever you divided by times 4x squared plus 6x minus 9 plus 1. Now you might be wondering, well, last time you put your quotient first. You did 4x squared plus 6x minus 9, and then you put this little guy. The order doesn't matter. Either one's okay, because with multiplication, it's commutative. Order doesn't matter. So 2 more quick examples. The last one I'll say for you to do. Make sure you have this all written down. Pause the video if necessary to get caught up. All right, last one here. So from now on, we don't always have to do long division side by side with it, or else that would defeat the purpose of it being so quick. So let's divide this cubic by this linear, and k again needs to be -3, the opposite. So I put on my coefficients, only my coefficients, put them in descending order, starting with cubic going down. I dropped the 3. Each of these numbers gets multiplied by k. And then that number goes in this row, and you add vertically. So 3 times -3 is -9. Add them, get 8. 8 times -3 is -24. Add them, get -3. -3 times -3 is 9. Add them, get -2. So here's your remainder. This one's your constant term, technically x to the 0, x to the 1, x to the second. So I have this times this, my quotient is right there, -2, or plus a -2, as you like. Last one I'm going to leave for you to try. I have a cubic divided by a linear. Notice it doesn't have to be a cubic. We're going to start doing quartics, like x to the 4th and then x to the 5th. All these examples had cubics. That was just coincidence. So just one thing to keep in mind, when you put your coefficients here, that'll be easy. But notice this is already in the form x minus k perfectly. So k in this case is 2. Or you could think, well, it's x minus 2, so I'm going to do the opposite and put 2 there. So make sure you divide with 2. That's what k is. And then write your summary statement, blank times blank plus blank. And we'll practice this in class next week. Make sure you have all this written down. Make sure you're comfortable with it, because there'll be a quick check Monday on a long division and a synthetic division example to see how you're doing so far. Have a great weekend.